Hey guys, Mr. P here. We are done with chapter 1 and on to chapter 2. Chapter 2 is the chemistry of life. Okay, chapter 1, if you recall, was all about what is science, what isn't science, what is biology, what isn't biology. We talked about organization and structure and function. We talked about some unifying themes in biology. We talked about the scientific method. And that leads us into probably the first chapter of true content. And that would be chapter 2. Okay, chapter 2 is all about organic molecules, the carbohydrates, lipids, nucleic acids, and proteins. But chapter 2 is also about subatomic particles and atoms and molecules and ions and isotopes. And if you've looked at the vocab sheet, a lot of vocabulary terms that you probably haven't heard about. Okay, like monomer and polymer and building blocks and making up larger molecules. That's going to be a common theme in this chapter. Okay, you've got to know what makes up what and how molecules are broken down from larger to smaller and how molecules are built from smaller to larger. Okay, so let's go ahead and get started. We learned in chapter 1 when we did organizational structure that atoms are the smallest basic unit of matter. Okay, and the word atom comes from the Greek word atomos, which means unable to be cut. Okay, that's a very good definition to have when we're talking about the smallest basic unit of matter. Okay, we cannot divide atoms out further or smaller unless you're talking about the subatomic particles. But a lot of times they're not considered the smallest, talking about the subatomic particles, because they're not typically found by themselves. Okay, protons always attract electrons and creating this atom that we know of as the smallest basic unit of matter. Okay, those subatomic particles are, remember, the protons, neutrons, and electrons, and we see those over here on this side. The nucleus of the atom is composed of protons and neutrons. Okay, those are found in the nucleus. Protons, remember, are positively charged, neutrons are neutral, and electrons, which are found outside of the nucleus in the orbitals, have a negative charge. Okay? The protons give the physical properties, and I want you to remember kind of this iteration here. Help you out. Proton starts with P, okay? And so protons give the physical properties of the atom. Okay, PPP, protons, physical properties, and positively charged. Okay, if you think about that, protons, think about P. Protons are positively charged and they give the physical properties to the atom. Gold is gold, and everybody knows what gold looks like, right? It's kind of yellowish, it's a metal, it's non-magnetic, it's valuable, it's very expensive. It's really soft for a metal, but all of those properties, physical properties, are properties that gold has because gold has 79 protons. Okay? If you added one proton to that gold atom, now all of a sudden you have 80 protons and you change the structure of the atom entirely. Just adding one tiny little positively charged molecule in a proton to an atom that has 79 already turns this gold atom with 79 protons into mercury with 80 protons. And if you've ever seen mercury, it's not gold. Okay, it's not solid. It's actually liquid at room temp. It's incredibly toxic, meaning that it's very bad for you. It's not gold colored. It's actually kind of lead gray color. And so the physical properties of this atom changes entirely with the addition of one proton. Neutrons have a neutral charge and they give the organism or the atom its radioactivity. Okay, one of the words that is a vocab word is isotope, and isotope is an atom of the same type with a different number of neutrons as normal. Okay, and so if an atom has 79 protons And let's just say, and I'm not quite sure how many neutrons gold has, but let's just assume that it's equal, okay? If a normal gold atom has 79 protons and 79 neutrons, then an isotope would be 79 protons, so it's still gold, but maybe it has 81 or 80 neutrons, okay? So if the neutron number changes, then the atom becomes an isotope. And isotopes are radioactive. Okay, a lot of times you hear like carbon-14 dating or kind of radioactive dating, radioactive decay, when you're talking about dating fossils or dating rocks. And they're using the half-lives and they're using the radioactivity in these neutron-rich isotopes to accurately date something. And then electrons, we say, are negative, and they are the ones that are outside the nucleus in these energy orbitals. But they are tiny, okay? You're 1 and 1800th the size of a proton. And so these protons are tiny to begin with, but electrons are incredibly small. Okay, they are in charge of bonding. So protons give the properties, neutrons give the radioactivity, and electrons are in charge of bonding. Okay, protons are positive, neutrons are neutral, electrons are negative. Here's an atom structure. If we look at the structure and we look at where the protons and neutrons and electrons are, notice that these P or plus signs are the positively charged protons. These red ones would be the neutral neutrons, okay? And the electrons are around the outside, on the outside of the nucleus. If this was the nucleus, then the electrons are on the outside, and they are in charge of bonding, right? But this is the atomic structure that you need to know, okay? Protons and neutrons make up the nucleus. They also make up the mass. Okay, and I apologize for my writing. I'm writing with a mouse. Here's your periodic table of the elements. You don't necessarily need to know where everything is, but I wanted to point out the fact that carbon, which is right here, nitrogen, which is right here, oxygen, and hydrogen are pretty much, and phosphorus, okay? These 5 elements are the most important 5 elements when we're talking about life and biology. Okay, all of these elements in here are always important in trace amounts. I mean, like sodium and potassium are really important too, but all of the organic molecules can be composed of pretty much just carbon, nitrogen, oxygen, phosphorus, and hydrogen. Okay, these are the most important ones. You're going to want to make sure you know that. Okay, now we need to talk about kind of 4 of the vocab words. And you were given the vocab sheet, and so I know you know what the vocab words are, but atom, we talked about was the smallest unit of matter. Remember, atom is composed of subatomic particles like the proton, neutron, and electron. Element is a pure substance that consists of only one type of atom. Okay, so if we're talking about gold, gold is made up of only gold atoms, and carbon is made up of only carbon atoms. Hydrogen is made up of only hydrogen atoms. If you start mixing gold atoms and silver atoms, you don't have pure gold as an element. Okay, you have a kind of gold-silver hybrid. Isotopes. Isotope we talked about before, remember, with the number of neutrons, but atom of the same element that differ in the number of neutrons. So if you have carbon, and carbon has 6 protons and 6 neutrons, if you differ in the number of neutrons from 6, then all of a sudden you get an isotope, and those isotopes are radioactive. Okay, if we think about this, carbon, give a pin, carbon has 6 protons and 6 neutrons, which gives us a mass of 12. If we increase the number of neutrons to 8 from 6, all of a sudden 6 protons plus our 8 neutrons gives us carbon 14. Okay, this is an isotope. This is normal carbon. Okay, normal carbon. This is our normal element. So hopefully this doesn't get confusing. Carbon 12 would be our pure element. It is our normal occurring carbon element. Carbon-14 would be an isotope because we changed the number of neutrons. This one has 6 protons and now 8 neutrons. Okay, this one has 6 protons and 6 neutrons. And then ion is an atom that gains or loses an electron. Once an atom loses an electron, okay, if we have carbon, which should have 6 protons and 6 electrons, and we minus 1 electron, we should have 5 electrons. And if you have 6 positives and 5 negatives, you should have a net balance of +1. Okay? So that is a positive ion. We call that a cation because cats have pos. And so cation would be positive. Okay, you probably heard that before. Negative charged ions are anions. Okay, and if we did the opposite, if we minused, well, you don't want to minus a proton. You want to add an electron. So if we have 6 protons and we add an electron, then all of a sudden we have 7 electrons. Now we have, a net of -1. Positively and negatively charged atom. Molecules and compounds. Molecules are the smallest unit of most compounds. Molecules can be written like O2. Okay, we now bonded 2 molecules or 2 atoms of oxygen together. That's how they would naturally be occurring. H2 is a molecule. If you contrast that with compounds, these are substances that formed by the chemical combination of 2 or more elements. Things like H2O or CO2 or H2SO4. Okay, things like that. These are compounds, these are molecules. Molecules are the basic unit of most compounds because you can see molecule, 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 molecule. They make up most compounds. Okay, that's where we're going to do it. Next time we're going to talk about chemical bonding like the ionic covalent, hydrogen bonds, and van der Waals forces. Until next time, see ya.